Hi, welcome to Data Ops Unleashed. My name is Angelo Carvalho. I'm a Principal Solutions Architect at AWS. I'm here today to talk about how AWS and Unravel Data help customers modernize their big data workloads with Amazon EMR. Let's start with some trends and challenges in big data. First is the sheer size and scale of data. The next 3 years, there will be more data created than in the prior 30 years combined. The old on-premises tools and data stores are not going to handle this kind of scale. Second, this data comes in from a variety of sources and are stored in silos. So this type of data is varied. So there are structured, unstructured, and semi-structured data being captured. So now that the data is being collected, so our customers, they want to gain new insights on top of this data. So organizations, they need to easily access and analyze all types of data, such as log files, clickstream data, voice, video, but people, they have diverse skills. They have different tools. So we need to enable those people and applications to access the data, but also we have to ensure security, privacy, and compliance regulations are met for the data. So organizations need to be able to carefully define, monitor, and also manage who has access to specific pieces of data. So if you were to collect and store and secure and process all that data on-premise, it becomes very time-consuming, very complex and expensive. If you were to pick up open source projects and set up the environments, it needs a lot of expertise to ensure the open source projects integrate well and are able to work with one another. So big data administration skills are hard to find. Even if you have taken care of that, the infrastructure does not scale as needed. The innovation and development is always limited by how much resources you have. And the costs, they add up very quickly. So there are a few commercial vendors who provide integrated big data platforms. So, but their pricing is tiered and frequently updated. So during every license renewal period, the cost will quickly multiply. And of course, any enterprise on-premise solution have some kind of lock-in, which makes it hard for you to quickly move out if that solution does not work anymore. So to address all these concerns, AWS built a managed big data platform that scales easily based on the processing needs while keeping low costs by paying only for what you use, and first of its kind to separate computing storage. So let's talk more about Amazon EMR. Amazon EMR makes it easy to process petabyte scale data using the latest open source big data frameworks such as Spark, Hive, Presto, HBase, Flink, and Booty. EMR runs directly against the data stored in your S3 data lake. You don't need to move that data or transform your data. Additionally, EMR offers 100% compliance with open source APIs. You don't need to change your application code when you move to EMR. So with EMR, you can easily create clusters and provision one or hundreds or thousands of compute instances to process data at any scale. So EMR automatically manage cluster sizes, and it will scales up or down based on utilization, and you only pay for what you use. Because you are running against S3 storage, you can have multiple clusters operating on the same data. EMR the couples compute and storage, give you the ability to scale independently. So for storage, you can take advantage of tiered storage of Amazon S3. And for compute, you can take advantage of EC2 spot instances to save up to 80% of cost of using on-demand instances. EMR also enables interactive analytics for data analysts and scientists through EMR Studio and deep integration with SageMaker Studio, allowing you to build, visualize, and debug applications easily. So we launched the first version of EMR in 2009, over 10 years ago, and we have been constantly innovation in areas such as performance to make sure EMR is the best place to run your Spark workloads, as well as workloads for other frameworks such as Presto and Rive. So let's see what's new in Amazon EMR. Let's start with cost and performance features. So Amazon EMR provides multiple performance optimizations features for Spark, for instance. So with Spark on EMR, you get over 3 times faster performance in a TPCDS 3 terabytes benchmark compared to standard Apache Spark. The 2 tenets here are, we will not break API compatibility, and B, performance improvements are out of the box. So with all enhancements, you can utilize the faster performance for your Spark workloads while still remaining 100% compliant with the open source API. So these enhancements in no way impact the open source API compliance. So EMR cluster can utilize the Graviton2 based EC2 instances. AWS Graviton2 processors that are custom designed by AWS. They use 64-bit ARM Neoverse cores. So the workloads running on Graviton2 based instances, they provide 11% better performance if you compare to previous generation of instances. So let me give you one example of optimization we've done on Spark on top of EMR. So dynamic size executors, for instance. So today on Spark, you have to specify the size of your executor. So your specifications should match the underlying instances to reduce wastage of resources. So dynamic size executor solves this problem for you. So you only submit the job, and we will figure out the size of the containers to ensure the most optimal infra utilization for you. So we started with Spark, but we kept the optimization. So for Spark, so we have 3.1 faster performance at 40% of the cost. But for Presto, we have 2.6 faster performance at 80% of the cost. And talking about the Graviton, we have 11% average performance improvement at 25.7% average cost reduction. Let me talk a little bit more about Graviton2. So now EMR supports the Graviton2 instances, and they will give you the best price performance in their instance family. So in the average, they will give you around 12 to 16% improvement in performance, and they are cheaper by 20% combined. So you can realize up to 30% better price performance if you use such instances. So we have hundreds of customers benefited from using Graviton2 instances from their big data workloads. And keep in mind that you don't have to change your application code in order to use those instances on EMR. also manage scaling. So we have our customers, they have been enjoying the auto scaling feature for a long time on EMR. So this is where you get to define the metrics based on which the EMR cluster can scale out or scale in to meet the varying demand of compute required for the cluster. But now you can enable EMR managed scaling to automatically increase or decrease the number of instances or units in your cluster based on the workload. EMR continuously evaluates cluster metrics to make scaling decisions that optimize our clusters for cost and speed. The difference is that with managed scaling, we manage the configuration, so no policies for you to define except for the minimum and maximum number of instances. So it's just simpler for you. So we manage the metric and the service decides when to scale up and down. So customers can save from 20 to 60% in costs. So of course, ultimately customers have data engineering and data science work to do. So we have investing to simplify development on top of EMR. So let's talk about ease of use functionalities. So EMR Studio. EMR Studio is an integrated development environment that reduces the time for your data scientists and data engineers to build and deploy code. So it's a fully managed application with single sign-on. It's based on Jupyter notebooks. It's automated infrastructure provisioning and job diagnosis. So you can use your corporate identity to log directly into the notebooks instead of AWS console. So you can develop, visualize, debug, and optimize analytics and machine learning applications. So Studio provides you a fully managed notebook based on Jupyter Lab, and it will gives you all the flexibility to create the notebooks independent of clusters. So basically you can attach and detach the notebooks to and from the clusters using a single click at any time. And the users, they can collaborate with peers by sharing notebooks via GitHub and other repositories. So you can collaborate your teams and you can analyze data together from data lakes using PySpark, Spark and SQL, Spark and Scala. You can also build pipelines using orchestration services such as Apache Airflow. But keep in mind that EMR Studio goes beyond standard Jupyter, right? It gives you one single IDE for interactive data analysis. So for example, EMR Studio users have additional options for real-time collaboration and also a full SQL Explorer. SQL Explorer is a feature within EMR Studio that provides data analysts who are working on SQL only an easy way to issue SQL query statements to their EMR cluster. So at the left pane here, you can see you have a data catalog browser where you can browse the databases, the tables, the columns in the data catalog. And the right-hand pane, you can issue SQL statements. You can open multiple tabs. You see the results of the statements and the results in the pane below, and you can download the results in the CSV format. So this is embedded in the Jupyter itself, and you want to switch to Spark notebooks. Now, this is just one click away within the same interface. So this aligns with our tenet that EMR Studio is a single IDE for interactive data processing. So for this release, we will be supporting Presto clusters, which is especially great for low latency queries. But Spark SQL support is coming soon. Mapbox is one of our customers that are using EMR Studio. Here you can see a statement for the head of data platform from Mapbox. Okay, so let's talk a little bit about transactional data lakes. We have some news as well for this. So Apache Rudy. So we have been supporting Apache Rudy for some time. Basically, it enables transactional data lakes on EMR, right? So it supports reader and writer isolation, concurrent writer support, record level upserts and deletes. And we recently added support for Spark SQL as well on Rudy on top of EMR. But now also we are adding support for Apache Iceberg on EMR. Apache Iceberg is an open source table format used at massive scale for building transactional data lakes as well. It was created by Netflix and Apple, and it's deployed in production by the largest technology companies and proven at scale on world largest workloads. In addition to the usual features of transactional data lakes like ACID transactions, multiple concurrent write support, time travel, Iceberg also is great on handling longer term challenges like full schema evolution, partition evolution, fast planning of queries across large tables with many partitions. So Rudy and Iceberg, they are at different points in time in their evolution journeys, right? So if you are especially looking for row level upserts and deletes and broad AWS support focusing on queries from Redshift Spectrum, for instance, or monitoring using AWS CloudWatch, Rudy probably should be your first choice. But if you are looking specifically for full schema evolution, partition evolution, etc., then you can use Iceberg. Okay, let's talk now about security. Well, EMR offers a comprehensive set of security features. For instance, for isolation, customers can use VPCs, where you can put your cluster inside of private subnets and you can have security groups to isolate your cluster inside in terms of network isolation. For authentication, EMR supports IAM, a single sign-on, Kerberos, and LDAP. For authorization, the default option is the cluster IAM roles, where you are going to define the authorizations for the cluster, but we have built in a new capability to enable user level execution role, right? So we enable fine-grained access control also using Apache Ranger and AWS Lake Formation. So basically you have many different options, right? So you can enable different options according to your needs in terms of authentication and authorization. EMR enables you to work with data when data is encrypted at rest or in transit. So for auditing purposes, EMR offers integrations with CloudWatch logs for Ranger and CloudTrail for Lake Formation. So many different choices here. Let's talk a little bit about different deployment options, because we have a lot of different options here. So the customers, they will have multiple options to run Amazon EMR, and they can even mix those options. So, so as shown in this slide, so EC2 will be the first one to explore. So EC2 will give you the broadest range of compute instance options in the cloud to allow you to optimize price performance, including the choice to use the Graviton2 processors. So customers can deploy on EC2, right, and use basically hundreds of different instance sizes, right? The second option will be to deploy Spark workloads, right, on containers on top of Elastic Kubernetes Service, AKS. This has the benefits of increasing the utilization of computing resource, simplifying the infrastructure management, and also taking the advantage of the fast startup, right? Because it's based on containers, so it runs really fast and starts really fast. And this includes the options to go serverless. But keep in mind that at this moment, Spark is the only big data framework supported by EMR on top of AKS, right? So, but if you want the benefits of a managed service, right, benefit of EMR, but you need to keep your environment on premises. AWS Outposts is still an option, right? So you can order an Outpost. It will ship to your on-premises location, and then you can launch EMR. But now we have a new deployment model that was introduced at reInvent 2021, and that was EMR serverless. So basically, you can run a petabyte scale applications without managing and operating clusters. So it can automatically scale the workers based in your workload, and this is now available for preview. So let's talk a little bit more about this new option, the Amazon EMR serverless. But let me begin with the primary motivation for why we built Amazon EMR serverless. As many of you know, with Amazon EMR on EC2, you can provision clusters of any size in minutes. EMR automatically installs and configures all the open source framework. So it also gives you a complete full control over the configuration, and you optimize for performance and for cost. And this is a great option for a lot of customers who want that flexibility. We also have some customers who want a simpler experience with open source frameworks, and that's what EMR serverless can enable, right? This simpler experience. So EMR serverless, it's simple to use because you don't have to configure or optimize or operate or secure the clusters to run the applications using open source frameworks, right? So the EMR serverless will provision and configure and dynamically scales all the compute and the memory resources required at each stage of your data processing application. So with EMR serverless, your jobs will run fast, right? So it includes the performance optimized EMR runtime for Spark, for Hive, and for Presto. And the EMR runtime is also API compatible with open source, and it's 2 times faster than the standard open source. So your jobs will just run faster, right? And since you just pay for the compute time and resource used, it's cost effective. Okay, but to help you to migrate to Amazon EMR, right? So we launched the EMR migration program. So let me explain what is this about. So we saw some key benefits of migration to EMR. That's great, but migrations to EMR involve a few moving parts. So customers would want to know, for instance, how exactly do we move this massive data set to EMR, and what is my total cost of ownership is going to be if I move to EMR, and how do we implement my security requirements, for instance, if I move to EMR. So in order to answer all those questions and streamline the migration process, we put this program together that we call the EMR migration program, or EMP. So the goals of the EMR migration program include the TCO reduction and accuracy. So by profiling the workloads, we can better understand which instance families and types will be the most optimized for cost. And also, we take a data-driven approach to determine the right migration strategy. So whether it's in phases, re-architecting workloads, or a lift and shift. So whichever adheres to the customer timelines and businesses and technical requirements. And also, we look for increased performance and accuracy. So with the data in reports that can now be leveraged, we can develop strategies on how to execute the migration to meet the customer's goals. So let's take a closer look at the EMR migration problem. So it's executed in 3 phases. So the first is the assessment phase. In this phase, we first collect some high-level information from on-premise environment, like the number of nodes, total vCPU and memory configuration, average and peak utilizations on the source cluster. So based on this information, we will put together initial total cost of ownership with Amazon EMR to give the customer an estimate of what their costs are going to look like with Amazon EMR. So we are going to conduct discovery meetings with the customers to learn more about their environments, the use cases, and specific requirements for migration, and address any technical concerns they might have. So to perform a detailed assessment of the cluster and profile the workloads, we engage our partner on Revel data. So we will let Revel software collect utilization data for about 2 to 4 weeks, depending on the size of the cluster and the complexity of the workloads. Once the data is collected and analyzed, we move on to the mobilize phase. So the second phase is the mobilize phase. So in this phase, we will deliver the insights from the assessment along with our ProServe team, our system integrator partners, who can be engaged to perform the migration. So based on the assessment, we put together a migration plan to migrate customers' data and applications to AWS. Once the migration plan is agreed upon, we move on to migrate and modernize phase. So this last phase is the migrate and modernize, right? So depending on the migration plan, we can either execute the migration in a lift and shift approach or workload fit approach for both the data and the applications. So once the migration is complete, we can implement some of the techniques for modernization to take the full advantage of what EMR has to offer. So at a very high level, that's the customer journey through the EMR migration program. So as mentioned earlier, we partner with Unravel Data to take a faster, more data-driven approach to migration planning. We are using a subset of Unravel product suite during the data collection period for up to 30 days. During this phase, we are looking to get a summary of all the applications running on the on-premises environment, which provide a breakdown of all workloads and jobs in the customer environment. We identify queued or failed jobs to migrate, so applications that failed to resource contention and or lack of resources, identify bursty applications or pipelines to migrate. For example, we would locate bursty apps to move to EMR where they can have sufficient resources every time those jobs are run in a cost-effective way via auto-scaling or managed scaling. We can also estimate migration complexity and effort required to move applications automatically. And lastly, we can identify queues suited for separate clusters. For example, if we identify long-running batch jobs that run at specific intervals, they might be good candidates for spinning a transient cluster only for that job. Here we have a public success case where GoDaddy moved 900 scripts to Amazon EMR with the help of Unravel, with excellent results where they managed to save 2,700 hours in data engineering and $650,000. We've worked with many customers to migrate from on-premises and other solutions to EMR. A good starting point is the EMR migration guide that you can download at the link shown. In addition, we offer free workshops on top of that. The Amazon EMR migration workshop is a virtual or on-site workshop, depending on the pandemic situation, that can jumpstart your Apache Hadoop Spark migration to Amazon EMR. So we recommend that your Apache Hadoop Spark admins, data engineers, or infrastructure engineers to be present. So if you have an Apache Hadoop workload on premises and you want to migrate to AWS Cloud, and so you are a good candidate. So fill in the form at the link above, and you can ask your AWS sales team to start the process. So complete the form, and one of our technical experts will contact you to discuss your qualification needs and potential dates. I hope you have enjoyed this session, and thank you very much for your attention.